Hi, in this video I will give an overview of the MATLAB. So what is MATLAB? So MATLAB is a tool for technical computing and visualization in an integrated environment. MATLAB is very powerful when it comes to matrices and vectors. So it's well suited for matrix manipulation and problem solving related to linear algebra, modeling, simulation and control applications. And MATLAB is very popular in universities and in teaching and research areas. So here you see a simple MATLAB example. Here we can define variables. In this case, x is a vector, and same with y. We can have for loops, while loops. We can use in built-in functions. So MATLAB consists of hundreds of, or even probably thousands of built-in functions you can benefit from. MATLAB has powerful features for plotting, etc. In this video I will go through the following topics. I will give a short overview of the MATLAB environment, the so-called integrated development environment, basic MATLAB syntax, an overview of how we can use vectors and matrices within MATLAB, how we can plot with MATLAB, how we can create scripts and user-defined functions. So first, a quick overview of the MATLAB IDE. So here you see an image of the MATLAB environment. We have the command window, we have the script editor, we have the current folder window, we have the workspace, and we have also the plot window. So I will go through these different windows in MATLAB. So now I have opened MATLAB, and here we have the command window. So let's start with the command window. Here we can enter commands. So let's say a equals to 2, like this. And then you can click enter, and then you see MATLAB responds with the value of this variable. Then you can enter a new variable, b equals to 3, like this. And then you can click sum these two variables like this, for instance, a plus b. And then you see MATLAB responds with the answer like this. So using MATLAB like this in the command window, it's like a very advanced calculator where you can use plus, minus, etc. And you have lots of built-in functions for sine, cosine, average, standard deviation, and all these mathematics functions. So that's the command window. You see when I enter or create variables here, they pop up in the workspace. So here you get a list of all the variables in the workspace of MATLAB. So I have this a variable which has the value 2, and then b has the value 3. Let's say we have c equals to a plus b, and then you see c pops up with the value 5 like this. You can also use some of the built-in functions, so we can type clear, and then all the variables are cleared from the workspace. And also we have this command, clear command, click enter, and then the command window is also cleared like this. So then you can define some new variables, x equals to 3, y equals to 4, z equals to x plus y, like this, and then it pops up here in the workspace. We can also here in the command window, if you want to get back the previous commands we use, so then we can just here click the arrow up, and then we get this list with all previous commands we enter. So then assume we want to make this write this command, then we can just select this one in the list, or if you want to clear, we can select this one in the list, etc. So you don't, in that way, you don't need to write the different commands once more. You can just get them from the list like this. Next is the script window. So you can click here to open the script window. With the script window, we open this editor where you can enter MATLAB scripts. A MATLAB script is typically a MATLAB program with multiple commands. So here we can define a script like this: x equals to 5, y equals to 7, and then we can calculate it, x plus y, like this. This way we can enter multiple lines of code within one script, and then we can just click the run button in order to execute all the lines within this script. So that's the script editor. Next, here we have the current folder. This is the folder on your hard drive where you store your script files. So this is a script file, and then typically you can save them in the current folder. If you want to change the current folder, you can just click here in order to change the current folder. You can also click on the M files in the current folder, and here you can get a more detailed description of the different files, like this. So we have also the toolbar where you have the home, where you find the new script, open existing MATLAB files. You can install add-ons. You can import data. Here on the plot toolbar, we have different plots we can use. Here we can open specific apps. This is the editor is for manipulating commands, etc. in the script editor. For instance, we can add comments. So we add comments just using the % sign, and then we can add a comment. This is a comment like this, and then the color will be green, meaning this is a comment, and this piece of line will not be executed. It's just a comment in order to tell the user what this code is doing. So that's the main part of MATLAB. We have the command window where you can enter one command at a time. We have the script editor where you can enter a MATLAB program that contains of multiple commands and multiple lines like this. We have the workspace window where you can get an overview of all the variables we are using in MATLAB and with the current values. Here we have a list of files in the current folder which we can change here, and we have the toolbar on the top. So this is the main windows that MATLAB contains of. Typically you want to use MATLAB to enter mathematical expressions like this. Here we have a function y of x equal to 3 times x plus 2 divided by 2. And here we have a more advanced function with two variables, x and y, and we have a square root, x square, etc. So MATLAB has built-in functions which you can use for this expression. So for x square we can use this symbol. Here we can use the expression symbol, we can use the square root. We have the natural logarithm, you can use this function. The 10 logarithm, you can use this log 10, etc. So let's see if you are able to write these expressions in MATLAB. So we will start with this simple expression and see how we can enter this expression in MATLAB. Let's go to MATLAB, and here, of course, we can use the command window or we can use the script window. So in this case, you can just start with the command window, then you can define y equals to 3 times x plus 2, and this should be divided by 2, so we need to have these parentheses divided by 2 like this. This is how we enter this mathematical expression in MATLAB. So let's see what's happening now when we click the enter key on the keyboard. And you see we get an error message because the variable x is not declared yet. So first we need to define the x variable, and then let's say x equals to 2, or 2, like this, and then we can define this mathematical expression. We can just use the arrow up in order to get it in from the list. And now x is already defined here, and now we can click enter here, and then MATLAB will calculate this expression and then MATLAB will respond with this with the answer. We can also try with another value of x. We can just click x equals to 4 instead, and then use key up and arrow up in order to calculate the expression once more with a new value of x like this. So let's see if we are able to enter this a little bit more advanced mathematical expression in MATLAB, where we need to use some of these built-in functions. So then we start to define these expressions. Set equals to 3 times x square, like this, plus the square root. Then we use this square root function, x square plus y square, like this, plus use this x built-in function, and the log function, like this. So now we have defined the function. Let's click enter to execute it, like this. And then we got this answer based on, so we have two variables here, x, which is equal to 4, and we have y, which is equal to this value. And we can enter different values for x. So let's say x equals to 2, y equals to 4, like this, and then we can get the expression by clicking the arrow up, like this, and then we can click enter once more, and then set is calculated for the new values of x and y. Next, we want to define some vectors and matrices in MATLAB, because MATLAB has powerful features for handling vectors and matrices. So let's see some examples. So here we see an example of a vector with 3 elements. Here we see a matrix, 2 times 2 matrix. So let's see how we can enter these vectors and matrices in MATLAB. So let's start to define this vector x equals to, and then we use these square brackets, and then inside the square brackets we just enter the values 1, 2, 3 in this case, and then we click enter, and then you see the vector x was defined like this. So we have used space between different values. We could also use comma like this, which should give the same results. Next, we can define a matrix. Let's have a matrix a equals to, and then use the same square brackets, 1, 2, and in order to separate the different rows, you use this semicolon, 3, 4, and then just click enter, and then we have defined this 2 times 2 matrix like this, using semicolon in order to separate the different rows. And then in order to separate column data, we can either use a space or we can use a comma like this. For vectors, we can also use the colon operator like this. So x equals to 1 colon 10. Click enter. And using this operator, we create a vector with these values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this. If you enter from 1 to 6, we create a vector from with 1, 2, 3, 4, 5, 6. If we do like this, then we enter a x vector with 1, 1.5, 2, 2.5, 3, etc. Because we have this interval or step size between the values within the vector. So assume we have the following rain data for a given week. So Monday, and the rain amount was 2.1 millimeter. Tuesday it was 10 millimeter, etc. Let's see how we can enter this data in MATLAB. So then we can just define a variable for this. We can use x equals to these square brackets, 2.1 on Monday, 10 on Tuesday, 9.7, 6.2, 2.5, 0, and then finally 8.5 like this. And then just click enter, and then you see we have defined a vector with these rain data. And then we can use some of the built-in functions to find the average and standard deviation, etc. So we can use, if you want to find the average rain amount for this week, we can use this mean function, and then we can just use x as an input to this function, and then just click enter, and then MATLAB is calculating the average rain amount for this week. You can use the standard deviation function in the same way, like this. You can also put the output of this function in a new variable. So let's create a function, a variable called average, like this, equals to mean x, and then click enter, and then the average rain amount was put into this variable like this. So now x is defined as this vector with 1, 2, 3, 4, 5, 6, 7 elements. We can also use, let's say we want to pick out some parts of this vector. Let's say we want just to have this 10 value, then you can use like this, x and parentheses 2, and then we get just this specific value. So we use the parentheses in order to get a specific part of the vector or a matrix like this. So x1 is equal to this one. x6 is the 6th element in the vector, which is 0 in this case. We can also use vectors in mathematical expressions. So assume we have the following function, y equals to 2 multiply with x square plus 3 times x plus 1 like this. And then click enter now, we need to define this x vector. We can set x equal to 1, and then we can execute y like this, and then we will get the value. But assume we want to calculate y for a set of data, and then we can define x as a vector. So let's define a vector from x equal to from 1 to 10, for instance, like this. So then x will be this vector of data, and then we can entering or calculate y for each value of x. So y will also then be a vector of data. Let's just try to calculate it the way like this, clicking enter. Then we see you'll typically get this error, because in this case x is defined as a vector, but y are still not supported to handle vectors, so we need to make some small changes to this expression. We need to use this dot notation, meaning it's an element-wise multiplication for each, in front of each expression. So here and here we need to just define this dot notation. So now we can click enter, and then y will be a value of corresponding data according to this formula. So this is a powerful way MATLAB can handle vector data, and you can also calculate values based on input where we use vectors as input data to a mathematical expression like this. As mentioned, MATLAB has powerful features for vectors and matrices. So let's assume you have two matrices like this, 3 times 3 matrices, B and C, and then MATLAB has built-in features for multiplying, addition, etc. on matrices. Let's try to define these two matrices in MATLAB, and then we can multiply them, etc. So I start to define these matrices. We can have matrices B equals to these square brackets 4, 3, 0 and semicolon to enter a new row. 1 minus 7, 2, semicolon for a new row, 8, 1 and 0 like this. And then we have defined this 3 times 3 matrix B, and then we can define the C matrix. Minus 1, 3, 0, 4, 7, minus 2, and 2, 0 and 9 like this, 9. So now we have the B matrix and the C matrix, and then we can just type B multiply with C like this, and then MATLAB will calculate the answer to this problem like this. You can use addition as well. B plus C, B divided by C, B minus C, etc. In addition, MATLAB has lots of built-in functions for matrix manipulation. We can use find the determinant of a matrix. We can find the inverse of a matrix like this. We can find the transpose of a matrix using this B and this like this. So MATLAB offers a lot of built-in functions that we can use in order to manipulate matrices and vectors like this. As mentioned earlier, MATLAB has also powerful features for plotting. Let's go through this example. Assume we want to plot the sine function from 0 to 2 pi like this, and then we can just define this x vector from 0 to 2 pi, and then we can define the function y sine x, and then we can plot it x comma y. So let's see how we can do this in MATLAB. So we start to define the x vector. X equals to from 0 to 2 multiply with the pi. Pi is a built-in keyword we can use. So then x is defined like this, and then we can find y equals to sine of x like this, and then we can just use the plot command, plot x comma y, and then we will get this plot of sine x. But you see here it's a little bit rough here, so we need more data points in order to plot it correctly. So you can just close it, and you define this x vector with more data points, so you can do like this, and then this x vector will consist of more detailed data point from 0 to 2 pi like this, and then we can define y once more, and then we can plot it. As you see in this example, with more data points, the plot will be much more smoother like this. In addition to the plot command, MATLAB offers different functions we can use together with the plot function. We can add the title. We can use title and then just enter a title. This is my plot or something, and just click enter. First, we first just need to define the plot once more, and then the title like this, and then you see we get a title of our plot like this. You can also get x labels here and y labels. Let's try that as well. So x label, we can just call it x, click enter. Let's see our plot, and then we get x on our x as an x label on the x-axis. Same with y label, like this, click enter, and let's see the plot. You got this on the y-axis like this. You can also plot multiple plots or lines in one figure. Let's see how we can do that. Assume we want to plot sine and cosine in the same plot or the same figure. So then we have defined this sine. Then you can define set equals to cosine like this. Like this. Then we can plot x comma sine. We used y, so xy, and then we can plot x comma set. So this is sine and this is cosine like this, and then we can click enter, and then we get both sine and cosine in the same plot. Sometimes it's difficult to know which of the plot is red and which is blue, so then we can create a legend. So we can use the legend function, legend sine of x, comma cosine of x, like this. Click enter and then see our plot. We get this small square in the upper right corner where we can see that the blue one is sine of x and then the red one is cosine of x, like this. So this is how we can use some of the built-in functions in order to create quite advanced plot in MATLAB. We can also create so-called subplots. So in this case we have sine in this upper plot, and then we have cosine in this lower plot. Let's see how we can do like this in MATLAB. So we have already defined our x vector, and y was equal to sine of x and z was equal to cosine of x, and then we can just use this subplot command. So it's just type 2 times 1 like this, and then we have defined the upper subplot of this figure, and then we can here and plot the sine of x. Then you can just type plot x comma y like this, and then let's see our figure now. And we got the sine in this upper plot, and here we want the sine. So then you can enter the subplot once more. Subplot, instead of 1 here we can enter 2, and then we have defined this lower plot as well, and then here we want to plot the cosine of x, and then we can just use the plot command, type x comma z, which was cosine of x, and click enter, and then our figure will be like this. So then we have the sine of x, and then we have cosine of x in a lower plot like this. So this is how we can use subplots in MATLAB. Next, I want to give an overview of the scripts and user-defined functions in MATLAB. So let's start with script. So scripts is just, as mentioned earlier, it's just a bunch of MATLAB commands that we write using this script editor. So let's just click new script, and then the script editor opens, and then here we can enter multiple lines of MATLAB code. So assuming we want to do this same code for plotting subplots, then we can just define this x vector from 0, 1.5, 1.1 to 2 multiplied with pi like this. And then you can define y equals to sine of x, and then z is defined as cosine of x, like this. And then you can define this subplot 2, 1, 1, and then use this plot x comma y, and then this next subplot 2 times 1 on second plot like this, and then plot x comma z like this, and then we can just click the run button, but first we just need to save it with a proper name, subplot example. Remember, these files will be saved with the .m extension, m for MATLAB, and the file name cannot contain spaces, so you need to use an underscore or something instead of spaces, like this, and then click just save, and then the script will be executed. And as you see, we got the same result here. We got the sine of x and then cosine of x in each subplot like this. So instead of enter all these commands in the command window, we can just enter all the commands in a script, and then we can save it for later within this file, and we can just click the run button in order to execute it like this. So this is a more useful way to create MATLAB programs using the script editor instead of using the command window like this. Instead of clicking the run button, we can also execute M files from the command window. We can just type the name of the script file, in this case subplot example, and click enter, and then the script will be executed. So far we have used many of the built-in functions in MATLAB, like the plot, the mean function, standard deviation function, etc. But sometimes, or very often, you want also to create your own function. So that's what I will go through now. So assume we have this simple formula where we want to convert the temperature in Celsius to the temperature in Fahrenheit according to this formula. So we will create a function for this mathematical expression, and then we can, when we have created the function using the script editor, we can use the function like an ordinary built-in function like this. So you just enter the name of the function and then enter the input arguments. In this case, the input arguments is tc, and then MATLAB is calculating or executing the function, and the corresponding temperature in Fahrenheit will be calculated by MATLAB like this. Let's see how we can do this in MATLAB. So in MATLAB we just select new script in order to open the script editor, and then we start using this built-in function keyword in order to define our user-defined function. So user-defined functions are functions we are making by ourselves. So we use this function keyword in order to do that, and then we start to define the return value. In this case it was TF, the Fahrenheit temperature, equals to the name of the function. We can call the function in this case Fahrenheit, and then a parenthesis with the input values, in this case TC, the temperature in Celsius. And then we can click enter here and start defining the output of the function according to the formula. So TF equals to 9 divided by 5 multiply with the TC plus 32. So this is the formula that convert from Celsius to Fahrenheit, and this is how we define this formula within a function. So next we just click save, and here we need to save our function as a file on our hard drive, and then you have to remember the name of the M file needs to be the same as the name of the function here. So this name is the function name, and this is the name of your file that is stored on the hard drive. These need to have the same name. So just click save in order to save it, and then this function is defined within MATLAB. You can find it here in the current folder here. You can also enter some comments here. This function converts from Celsius to Fahrenheit. Click save. This, and then you see this help text is, or this comment is popping up like this. You can also type here in command window help and the name of the function, and then you will get some help about these specific function. And you can also do that on the built-in function. So help plot gives help on the built-in plot function like this. So let's go back to our function. Now we want to use this function in the command window, so then we can start entering some temperature in Celsius. Could be 45 or something, and then we can use our function like this. So this is the name of the function, this is the input argument, and this TF will be the return value. So let's just click enter, and then you see MATLAB is calculating the corresponding Fahrenheit value based on our input value in Celsius. So this is how we create and use our own functions within MATLAB. So that's all you need to know in order to start using MATLAB and create your own functions and scripts, and in order to use MATLAB for real applications. So good luck with MATLAB.